So hi everyone. So we'll just continue with the function questions, and that will be end of our set theory and algebra. Obviously I will add anything if something comes, or if I get any request from someone. So the thing is that yesterday I uploaded one video on functions. Actually I feel like I rushed through the concept. So if you have any doubts, you can mail me. So because actually I had some Google Meet with our seniors, just immediate seniors, about something, PhD and all. So I mean, I'm not applying on anything, I'm just first year, only 1 month of MTech. So if I felt like when I was watching my video, I felt like I may have rushed through it. So if you have any problem with the video, you can always mail me or comment down, anything. Mail is obviously a better option. So that's it. We'll continue with questions. Okay, so now this is a basic question. It was asked in 1996, 1 mark question. Okay, so same type of question we have already practiced, but anyhow it was asked in GATE, that's why I've taken the question. So it is easy. Okay, you can anyways do it. You can pause the video and do the question, solve the question and check the answers with. Okay, suppose x and y are set. So x and y are their respective cardinalities. Okay, so it is given that exactly 97 functions from x to y. So from x to y, this is very important. This ordering is very important, from x to y. So the here this is our x set, this is our y set. Okay, so now we knew this if it contains m elements, it contains n elements, number of function will be n to the power m. Okay, so this has to be our formula. So now if we do, we have to find out 97 functions, has to be totally 97 numbers of functions has to be possible. So this number has to be 97. So now let's take the option one by one. So first one is cardinality of x is 1 and cardinality of y is 97. So this is basically our option. 97 to the power 1 is equals to 97. So this is option is correct. Let's see other options also. So cardinality of x is 97 and y is 1. So what it is, see, it may look similar, but it is 1. Okay, so these things are not equal. Okay, so this is coming as 97, this is coming as 1. So this is very important. I have taken same kind of example in our when we are doing functions, but this is very important. So this is actually false. So this is basically our correct option, and this is basically something else, 97 to the power 97. So this will go something else, and none is not the option. So option A is correct. Okay, so I hope this is easy. Just don't get confused between these two. Okay, so that's why I'm telling to remember this orderings. Okay, so the orderings, see how this is coming and all we have already discussed. I hope you watched, or if you don't watched, if you still have problems, so please go back and watch that video. So, and also I have numbered properly now, since I have got so many comments and that my videos are like not numbered. So mathematics, this set theory and algebra, I have numbered properly. Please go in that order. And others, algorithm and C data structure, I haven't got time, I will number them. So this is, so I have numbered them properly. You can go one by one. Okay, so this how it is coming we have already discussed. Okay, so now I'm not going to elaborate it because it will just waste your time. It's already there, you can just see the video. Okay, so that's it. We will see next question. So now let's see this question. Okay, it may look big, but it is actually not. Okay, this is not given. Okay, this is just an example, counter example, so that we can find out. Okay, let's see the question first. So this was asked in GATE 2005, 2 marks question. Let a function b arrow c and a function g, a arrow b, be two functions, and let this. Okay, h is just a multiplication of f dot g. Okay, so h is a compilation of both the functions. And what is h? Given that h is an onto function. So what is onto? Just simply I am recalling again. So b, every element of this b has to be at least one element of mapped with at least one element of a. Okay, so this is basically our onto function. So at least one element of here, it will be mapped to one element of a. Okay, one second. Okay, so I thought my mother was calling. Anyways, so now from this image, not image, every point has to be mapped with at least one element of A. So this is basically our onto. So now we have taken an example here. So this is F and this is G. So total is onto function. Okay, so now we have to find out G is onto, F is onto or not. Okay, means if it is, it has to be onto or not. So the options are giving like this: F and G should be onto functions, F should be onto but G need not be onto, the other ways both need not be onto. So this is the 4 ways. So now let's see. Okay, so here I have taken one example. So you can see this part is onto. Okay, but this is not onto because this element has not an image in this part. So here from this H, if H has to be onto, this part, all these elements has to have an image in this part, because if the whole thing has to be onto, this the right portion will have an image, pre-image in this B. So F always has to be onto. From this diagram we can say that F has to be onto always, but here just an counter example is this. So G need not be onto. It can be onto obviously, but need not be onto. So this stands. So the whole thing stands as H is onto. So our option should be F should be onto but G need not be onto. Okay. So this is option B is our correct option. So this part always has to be onto, this may not be onto, so the whole thing will stand as onto function. Okay. So a similar kind of question is present in 2005 IT paper. I am not doing that. You please solve that. So if you have any problem, I will upload another video, but it's like an exercise for you. Please solve that. Okay. So try finding out the question and do solve that. It's a similar kind of question. So it was CS paper. Okay, back then it has got 2 papers, CS and IT. So IT paper, same kind of question I just saw was present. So you please solve that. So it will give you a practice. Now let's see this example. This is actually an easy one. So might confusing, but do one step by step. Okay, so it was asked in GATE 2001. I think 1 mark question. I think 1 mark. Okay, so let X, Y, Z be sets of sizes X, Y and Z. So these are sets. The cardinality of X is X, cardinality of Y is Y, and cardinality of Z is Z. Okay, so now W is equals to X into Y. Okay, so W is containing X into Y, so it is containing XY. Small xy is actually number of elements present. So E be the set of all subsets of W. So I think you remember this. This is actually power set of all subsets. So E is 2 to the power xy. Okay, so this is our E, set of all subsets of W. So the W is this and E is set of all subsets, so it is containing 2 to the power xy. So now next the asked question is the number of functions from Z to E. So Z to E, so this is our Z, this is our E, this from this to this, from Z to E. Okay, so visualize it like this. Okay, so now the function, the actual answer will be 2 to the power x into Z. Okay, so just if you do the opposite one, it will come down to a Z into 2 to the power xy. Okay, so please be very careful. Okay, so we have already seen this, how it is coming, this to the power this. Okay, so now this was this, let me write it down. Okay, I don't know, I am not convinced that you have understood. So this is Z, this to the power this will come down to as this. Okay, 2 to the power xy to the power Z is actually 2 to the power xy z. Okay, so I have elaborately told you. I hope this is understandable. Okay, so the correct option is option D. Okay, so if you do the opposite one, this will come as this answer. Okay, so please be very careful from this to this. Okay, so don't do silly mistakes. So I think another 2 or 3 questions are left from functions. We will do that and then we'll be able to say that we have completed set theory and algebra in a proper way. Okay, so let me upload this.